Hello, welcome to the Mark Janard Show, the cybersecurity show. Let's talk about this gpt-oss, right? It is going crazy right now. It's all over, and I'm going to break it down. I'm going to slow it down so that you can understand it a little bit, right? So gpt-oss refers to a new family of open weight language models released by OpenAI, the gpt-oss 20b and the gpt-oss 120b, designed to run locally, offering developers and organizations full control, customization, and transparency with an open source Apache 2.0 license. So these models are positioned as a major step forward. Please take a moment to hit the subscribe button and the like button. Please take a moment to hit the subscribe button and the like button. An accessible, customizable AI, and mark the first open weight release from OpenAI since GPT-2 in 2019. Now, gpt-oss 20b has 21 billion parameters and can run on consumer hardware with 16 gigabytes of memory, while gpt-oss 120b has 117 to 120 billion parameters and requires about 80 gigabytes of GPU memory. Both use a mixture of experts, right? MOE architecture, which activates only a fraction of the total parameters per token for efficiency. So these text-only models, not multi-model, which is no image slash output, audio output, right? But they perform advanced reasoning, right? They supporting strong instruction following, chain of thought processes, structured outputs, and can act as, basically searching the web, running the code, those kinds of functions, right? So the models are designed for local deployment, enabling use cases where privacy, latency, and on-premise control are essential, such as summarizing documents, code analysis, and integrating into secure enterprise workflows. So OpenAI released the training details, architecture, and supporting open source tools / documentation. So safety was a priority. So with basically with the extra red teaming and post-training instruction hierarchy to help enforce privilege levels. It's the system, developer, user, assistant, and then tool. And mitigate prompt injection risks, right? So both models are licensed under Apache 2.0, allowing commercial use, redistribution, and integration into other projects with a minimal use policy requiring legal and responsible usage. So real world performance is strong, right? The gpt-oss 120b is reported to achieve near parity with OpenAI's latest proprietary O-series models on major reasoning benchmarks, while gpt-oss 20b is suitable for personal and on-device setups. Now, to run gpt-oss, OpenAI's open weight language model, you have to start by selecting the model size, whether it's the 20b or 120b parameters and environment. So the most commonly supported runtimes are the Hugging Face Transformers, the VLLM, the Ollama, and the LM Studio. So now I'm about to go to a little bit of a walkthrough for the, using the 20B version, but the steps are somewhat identical, virtually identical for the 120B variant. Now, the prerequisites you're going to need is to install the required packages, right? The pip install uTransformers torch, right? Running via transformers, the Python API, and I have an example code here. Peter, please put that on the screen for the viewers, right? You must use the Harmony response format, either automatically via the chat template or the OpenAI Harmony package. Then running as an API server, the transformers serve as, this code that Peter's going to put on the screen. Now, using the VLLM after installing via UV, you have to run, locally with the Ollama. Now, the commands are here. Peter, put that on the screen for them. Now, this is ideal for consumer hardware and simple setups. Now, you're going to have to download the weights directly. So Hugging the Face CLI, Peter, you could put that on the screen for them. Adjusting the reasoning levels, right? gpt-oss supports low, medium, and high reasoning levels set in the system prompt. So the reasoning, is like high, as an example, right? Then the fine-tuning, both models can be fine-tuned, the 20B model on consumer hardware and the 120B on a single H100 GPU node. Now, here's a technical example, of fine-tuning the gpt-oss models for specific tasks and domains, right? Synthesized from, tutorials all over the place and guides, right? So you're gonna have to define the use case clearly, right? To, identify the specific task or domain problem you want to, basically the GPT-oss model to solve. This precision guides data selection, model choice, and evaluation. As an example, you may want a medical Q&A assistant, right? That's a domain-specific expert model, or a customer support chatbot tailored to your company's product details. Then you're gonna have to collect and prepare the data. So gather domain-specific text data aligned with the task, right? Whether it's the legal documents, the medical journals, the chat logs, the FAQs, etc. as an example, right? Then annotate and or label the data if needed, right? Question answer pairs, dialogue turns as an example. Then you're gonna have to clean and pre-process the text. So remove irrelevant info, normalize casing, strip special characters, and split into training, validation, and test sets. You have to ensure the data quality as it critically impacts fine-tuning success. Then you have to select the base GPT-oss model. So choose an appropriate GPT-oss variant according to your computational resources and complexity needs, right? Whether it's the GPT-oss 20B or the GPT-oss 120B model. So larger models offer better reasoning but require more hardware, okay? So set up the fine-tuning pipeline. So use frameworks like Hugging Face Transformers with specialized trainers such as the SFTT trainer, right? The SFT trainer. Load the base GPT-oss model and tokenizer. Then configure training parameters including learning rate, number of epochs, then the batch size, right? So it's optional but not optional, right? As far as include advanced fine-tuning techniques such as reasoning, chain fine-tuning, right? Training on a step-by-step reasoning, or a multi-turn conversational training to improve model reasoning and dialogue handling, right? In regards to fine-tuning the model, you have to train on the prepared data set, monitoring, the metrics like the training, the validation loss, and domain-specific quality, whether it's the accuracy, the factual correctness in domain. You can use tools like the weights and biases for experiment tracking and custom evaluations to detect overfitting and degradation. You have to evaluate and iterate, right? So rigorously test the fine-tuned model on held out data or real-world task scenarios to assess performance. Then evaluate domain-specific requirements, right? As an example, precision in terminology usage for medical models or relevance in customer responses for support bots. Now, iterate by updating training data, tweaking hyperparameters, or basically applying more training epochs as necessary. The next step is leveraging the advanced capabilities. So fine-tuned GPT-oss models retain core functionalities like function calling to interact with external APIs, web browsing for up-to-date info, and code execution. So incorporate these for enhanced task-specific applications, whether it's the medical GPT calling research databases. Deploy and monitor, right? Deploy the Apache licensed model in your own infrastructure for full control and privacy. Y'all want to monitor the reasoning quality, right? Response latency and user satisfaction to maintain performance over time. Apply continuous fine-tuning with newly collected data to keep the model up to date. So we talked about it a little bit, but I'm going to get into more about the differences between the GPT-oss 20B and the GPT-oss 120B models, right? Now, aside, we talked about the 120B has 117 billion total parameters. The 20B has 21 billion total parameters, right? So we talked about that. However, there's active parameters per token due to the mixture of the expert's architecture. So GPT-oss 120B activates about 5.1 billion parameters per token. GPT-oss 20B activates about 3.6 billion parameters per token. Now, the memory requirements and deployment also sees differences as well. So the GPT-oss 120B requires roughly an 80 gigabytes GPU to run efficiently, while the GPT-oss 20B can run on consumer hardware with as little as 16 gigabytes of memory, making it suitable for local on device inference. Now, for the performance and the use cases, GPT-oss 120B achieves near parity with OpenAI's O4 mini model on core reasoning benchmarks and outperforms it on competition math and health benchmark. So it is preferred for high-end tasks on a single high-memory GPU. Now, the GPT-oss 20B delivers comparable results to OpenAI's O3 mini model, which is still surpassing it on some competition math and health tasks, right? So it is optimized for faster iteration with low-cost infrastructure and edge device applications. Now, the training and fine-tuning, we talked about that, but let's get a little bit more into that, right? Both models were trained with similar advanced techniques, including chain of thought, reasoning, and reinforcement learning, but the 120B model training required about 10 times more compute, which is 2.1 million H100 GPU hours than the 20B model. So both models support adjustable reasoning effort, that's the low, medium, and high, and use grouped multi-query attention and rotary position embedding, also known as the ROPE, with context lengths up to 128K tokens. So that's what I have for today. Please take a moment right now to hit that subscribe button and the like button. I appreciate your viewership. Stay safe and see you on the next video.